March 15, 1944. The morning mist clings to the runways of RAF Debden in Essex, England. Through the grey dawn, the distinctive roar of Merlin engines cuts through the air as silver P-51 Mustangs return from their latest escort mission deep into German territory. 3 aircraft bear the scars of combat. Bullet holes pierce wings and fuselages. One fighter trails a thin stream of coolant, its radiator damaged by cannon fire. Another sports a shattered canopy, testament to a close encounter with a Messerschmitt's guns. By the time the pilots shut down their engines and climb from their cockpits, American ground crews are already swarming the damaged aircraft. Toolboxes appear as if by magic. Patches of aluminum sheeting materialize. Within minutes, the sound of riveting hammers echoes across the airfield. What happens next would have seemed impossible to the German pilots who had inflicted this damage just hours earlier. By sunset, all 3 fighters would be airworthy again, ready for tomorrow's mission. This scene, repeated daily across dozens of American air bases, represented a revolution in military aviation that caught the German Luftwaffe completely off guard. The year 1944 marked a turning point in the air war over Europe, though not for the reasons most people remember. While historians often focus on the dramatic dogfights and bombing campaigns, the real revolution was happening on the ground. American mechanics and ground crews had developed a maintenance system so efficient that it fundamentally changed the mathematics of aerial warfare. The P-51 Mustang had entered combat with the 8th Air Force in late 1943, but it was during the spring of 1944 that its true potential became apparent. These weren't just superior fighters in terms of performance, they were aircraft supported by a maintenance infrastructure unlike anything the world had ever seen. Every P-51 squadron was backed by teams of specialists who could perform what seemed like miracles of mechanical restoration. The foundation of this system lay in American industrial thinking applied to military logistics. Unlike European air forces, which traditionally relied on small teams of highly skilled craftsmen to maintain aircraft, the Americans had developed a factory-style approach to field maintenance. Each ground crew was organized like an assembly line, with specific roles and standardized procedures that could be repeated endlessly. The typical American fighter group in England consisted of 3 squadrons, each with roughly 25 P-51s. Supporting these 75 aircraft were over 400 ground personnel. This ratio seemed extravagant to European observers, but it created redundancy and specialization that paid enormous dividends. While German mechanics often worked alone or in pairs, struggling with shortages of parts and tools, American crews worked in teams of 8 to 12 specialists per aircraft. Supply lines stretched back across the Atlantic to factories in North American aviation's plants in California and Texas. But more importantly, they connected to a network of depot-level maintenance facilities that had been established across England. Major repairs that would ground a German fighter for weeks could be completed by American depot crews in days. Components flowed through this system with the regularity of a heartbeat. The Americans had also revolutionized spare parts logistics. Instead of waiting for specific components to be manufactured and shipped, they maintained enormous stockpiles of commonly needed items. Engine components, propellers, landing gear assemblies, and avionics systems were stored in quantities that would have seemed wasteful to resource-conscious European militaries. This abundance meant that repairs rarely waited for parts. Training played an equally crucial role. American ground crews attended specialized schools before deployment, learning not just how to maintain P-51s, but how to maintain them quickly under combat conditions. They practiced procedures until they could perform complex repairs almost blindfolded. Time trials were common, with crews competing to see who could change an engine fastest or patch the most bullet holes in an hour. The psychological impact of this system on American pilots was profound. They flew with confidence knowing that minor battle damage wouldn't ground their aircraft for weeks. A pilot who returned with a shot-up fighter could reasonably expect to fly that same aircraft within days, sometimes within hours. This reliability created a feedback loop of aggressive tactics and high operational tempo that German pilots found increasingly difficult to counter. Meanwhile, the German Luftwaffe was experiencing a maintenance crisis that grew worse with each passing month of 1944. The industrial infrastructure that had once supported German aviation was crumbling under the weight of Allied bombing campaigns and raw material shortages. German aircraft manufacturers were struggling to produce new fighters, let alone maintain adequate supplies of spare parts for existing aircraft. The contrast couldn't have been starker. While American P-51 squadrons maintained operational readiness rates of 80 to 90%, German fighter units were lucky to keep half their aircraft serviceable at any given time. Spare parts had become so scarce that German mechanics were forced to cannibalize damaged aircraft to keep others flying. Engines that should have been replaced after 100 hours of operation were being run for 200 or 300 hours, leading to frequent mechanical failures. German pilot training had also deteriorated catastrophically by 1944. New Luftwaffe pilots were receiving as little as 150 hours of flight training before being sent into combat, compared to the 400 hours that American pilots typically accumulated. But even experienced German pilots were flying less frequently due to fuel shortages and aircraft availability problems. The average German fighter pilot in 1944 flew perhaps 60 hours per year, while his American counterpart accumulated twice that amount. This disparity in flying time meant that German pilots had fewer opportunities to develop the split-second timing and tactical awareness necessary for air combat survival. More critically, they had less experience with their own aircraft systems. American pilots flew the same P-51 repeatedly, developing an intimate knowledge of its quirks and capabilities. German pilots often flew whatever aircraft happened to be available, never developing the deep familiarity that comes with consistent aircraft assignment. The psychological pressure on German pilots was enormous. They knew that any significant battle damage meant weeks or months of downtime for their aircraft. This knowledge encouraged defensive tactics and reduced willingness to engage in extended combat. German pilots learned to break off engagements quickly, preserving their aircraft for future missions. But this conservative approach played directly into American tactical advantages. Fuel shortages compounded every other problem. German fighters were operating on synthetic fuels that reduced engine performance and increased maintenance requirements. These fuels burned hotter and dirtier than aviation gasoline, causing accelerated wear on engine components that were already in short supply. Ground crews worked longer hours for diminishing returns, keeping fewer aircraft operational despite heroic efforts. The organizational structure of German maintenance also worked against efficiency. The Luftwaffe maintained a traditional apprenticeship system where mechanics learned through years of experience rather than standardized training programs. While this produced highly skilled individuals, it created bottlenecks when experienced personnel were killed or transferred. Unlike the American system, which could replace personnel with similarly trained individuals, the loss of a senior German mechanic could cripple a unit's maintenance capability for months. Communication and coordination problems plagued German maintenance operations. Supply requests moved slowly through military bureaucracy, often taking weeks to process. Even when parts were available, transportation networks damaged by Allied bombing made delivery unreliable. German ground crews never knew whether critical components would arrive in days or months, making maintenance planning nearly impossible. These systemic weaknesses created a vicious cycle. As man aircraft availability declined, each remaining fighter became more precious, leading to even more conservative tactics. Pilots who might have pressed an attack in 1942 now disengaged at the first sign of significant opposition, knowing that a damaged aircraft meant their squadron would have one fewer operational fighter for weeks to come. The mechanical innovations that enabled American maintenance superiority went far beyond simple organization and supply lines. American engineers had redesigned fundamental aspects of aircraft maintenance, creating systems that seemed almost magical to outside observers. The P-51 Mustang itself was designed with maintenance in mind, featuring access panels and component arrangements that allowed rapid servicing. But the real innovation lay in the tools and techniques that American ground crews brought to their work. American mechanics carried standardized toolkits that could handle 90% of common maintenance tasks. These weren't the traditional hand tools that European mechanics had used for decades, but specialized implements designed specifically for aircraft maintenance. Pneumatic rivet guns allowed rapid structural repairs that would have taken hours with traditional methods. Hydraulic jacks could lift entire engine assemblies in minutes rather than the hours required by manual hoists. The Americans had also perfected the art of battlefield repairs using materials that would have been considered unsuitable by peacetime standards. Aluminum patches held in place by special adhesives could restore structural integrity to damaged wings and fuselages. These repairs weren't meant to last forever, but they could keep aircraft flying until proper depot-level maintenance could be performed. German mechanics, trained in traditional methods that emphasized permanent solutions, often spent valuable time on repairs that American crews would have completed with temporary fixes. Training methods represented another crucial innovation. American ground crews didn't just learn how to maintain P-51s, they learned how to maintain them under combat conditions. Training exercises simulated the stress and urgency of wartime operations. Crews practiced working in darkness, under simulated enemy fire, and with limited resources. They learned to prioritize repairs based on mission requirements rather than engineering perfection. The psychological dimension of American maintenance doctrine was equally important. Ground crews were taught to think of themselves as combatants whose weapons were wrenches and rivet guns rather than machine guns and cannons. This mental framework created a sense of urgency and purpose that translated into remarkable performance under pressure. American mechanics took personal pride in keeping their assigned aircraft operational, often working through their official rest periods to ensure maximum availability. Quality control systems ensured that rapid repairs didn't compromise safety or reliability. Every maintenance action was documented and inspected according to standardized procedures. This systematic approach prevented the kinds of mechanical failures that had plagued other air forces attempting to increase maintenance speed. American pilots could trust that their aircraft had been properly serviced, even when repairs had been completed under intense time pressure. The Americans had also revolutionized parts manufacturing and distribution. Critical components were designed for rapid replacement rather than long-term durability. This approach seemed wasteful to European observers, but it reflected a fundamental shift in military thinking. American strategists understood that in prolonged warfare, the ability to maintain high operational tempo was more valuable than individual component longevity. Standardization played a crucial role in maintenance efficiency. Unlike German aircraft, which often featured unique modifications or locally manufactured components, American P-51s were built to exacting standards that ensured interchangeability. A pilot who flew aircraft serial number 44-13926 today could fly 44-15342 tomorrow with complete confidence that all systems would operate identically. This standardization extended to ground equipment, tools, and procedures. Communication systems linked maintenance crews with pilots, operations staff, and supply personnel in real-time networks that enabled rapid decision-making. When a pilot reported mechanical problems during mission briefings, ground crews could begin gathering necessary parts and tools before the aircraft even landed. This preparation reduced turnaround times and increased the probability that aircraft would be available for subsequent missions. The cumulative effect of these innovations was a maintenance system that operated like a finely tuned machine. Each component reinforced the others, creating capabilities that exceeded the sum of their individual parts. German observers who witnessed American maintenance operations often struggled to understand how such rapid repairs were possible, attributing American success to superior resources rather than superior methods. From the German perspective, American maintenance capabilities seemed to violate the natural laws of mechanical engineering. Luftwaffe pilots and ground personnel had been trained in traditional European methods that emphasized craftsmanship and precision over speed and volume. The idea that aircraft could be repaired quickly without compromising quality challenged fundamental assumptions about aviation maintenance. German fighter pilot Adolf Galland, one of the Luftwaffe's most experienced leaders, later wrote about his amazement at American operational tempos. German intelligence reports consistently underestimated American aircraft availability, leading to tactical planning based on false assumptions. When German formations encountered American fighter groups that should have been grounded by previous battle damage, the psychological impact was devastating. The technological gap extended beyond maintenance techniques to the fundamental design philosophy of aircraft systems. German engineers had created aircraft that were marvels of precision engineering, but this precision came at the cost of maintainability. The Messerschmitt Bf 109, Germany's primary fighter, required extensive disassembly for many routine maintenance tasks, Changing spark plugs on a Bf-109 engine required removing cowling panels and accessing components through cramped spaces. The same task on a P-51 could be completed in minutes through easily accessible maintenance ports. German industrial practices had evolved during peacetime, when aircraft were expected to operate for years with minimal maintenance. This long-term thinking produced robust, well-engineered aircraft that could operate reliably under normal conditions. But wartime operations imposed stresses and damage patterns that peacetime designers had never anticipated. German aircraft were over-engineered for normal operations and under-designed for combat maintenance. The human factors that drove American success were equally alien to German military culture. American ground crews operated with a level of autonomy and initiative that would have been unthinkable in the hierarchical German military system. American sergeants made maintenance decisions that German systems reserved for commissioned officers. This delegation of authority enabled rapid responses to changing conditions, but required a level of trust between officers and enlisted personnel that German military tradition had never encouraged. Resource allocation reflected fundamentally different strategic priorities. American military leaders understood that ground crews were combat multipliers whose effectiveness directly influenced air superiority. German leadership continued to view maintenance personnel as support troops whose primary function was to preserve expensive aircraft. This difference in perspective translated into different training priorities, equipment allocations, and operational authorities. The social dynamics of American maintenance crews also contributed to their effectiveness. Unlike the rigid class distinctions that characterized European militaries, American crews operated with relatively flat hierarchies that encouraged communication and collaboration. Mechanics felt comfortable suggesting improvements to procedures or reporting problems without fear of retribution. This open communication enabled continuous improvement and rapid adaptation to changing conditions. Intelligence gathering capabilities gave American maintenance planners significant advantages in anticipating problems and preparing solutions. American technical intelligence teams systematically analyzed German aircraft and weapons, identifying vulnerabilities and developing countermeasures. This information flowed back to maintenance crews, who could prepare specific tools and techniques for dealing with known enemy capabilities. The psychological impact on German pilots was profound and cumulative. Early in the war, German pilots had enjoyed significant advantages in aircraft performance and pilot training. But as American maintenance capabilities matured, these advantages eroded. German pilots found themselves facing opponents who flew aircraft that seemed immune to the normal attrition of combat operations. Combat reports from German pilots increasingly reflected frustration and disbelief at American aircraft availability. Formations that had been decimated in morning combat encounters reappeared in afternoon missions with apparently identical aircraft. German pilots began to suspect that American industrial capacity was even greater than intelligence estimates suggested, never realizing that they were often fighting the same aircraft they had damaged hours earlier. The strategic implications extended far beyond individual combat encounters. German Air Force planners had based their tactical doctrines on assumptions about American operational capabilities that proved increasingly inaccurate. Plans that anticipated American fighters being grounded by battle damage for days or weeks had to be constantly revised as American aircraft returned to combat within hours. The true test of American maintenance superiority came during the massive air battles of spring and summer 1944, when the 8th Air Force launched its most ambitious operations deep into German territory. Operation Argument, better known as Big Week, demonstrated the decisive advantage that superior maintenance capabilities could provide in sustained aerial combat. February 20, 1944, marked the beginning of 6 days of continuous operations that would push both American and German air forces to their limits. The 8th Air Force launched over 1,000 heavy bombers on each day of the offensive, each formation escorted by hundreds of P-51 Mustangs. For German defenders, this represented an unprecedented challenge. Never before had they faced such sustained pressure over such an extended period. On the first day of operations, the 357th Fighter Group encountered heavy resistance over Brunswick. Major Thomas Hayes led his P-51s into combat against a formation of Messerschmitt Bf-109s and Focke-Wulf 190s that outnumbered his squadron by nearly 2-1. The engagement lasted over 30 minutes, with aircraft from both sides sustaining significant battle damage. When Hayes's squadron returned to RAF Leiston, 8 of their 12 aircraft bore the scars of combat. What happened next would have seemed impossible to German observers. Within 4 hours of landing, 7 of the 8 damaged aircraft were declared combat-ready. Ground crews had patched bullet holes, replaced damaged components, and restored full operational capability to aircraft that should have been grounded for days. The 8th aircraft, with more extensive engine damage, was repaired and returned to service within 18 hours. This pattern repeated across dozens of American air bases throughout England. Aircraft that participated in morning combat missions were repaired and returned to afternoon operations. The cumulative effect was that American fighter strength actually increased throughout the week, while German capabilities steadily declined. German pilots found themselves facing fresh aircraft and rested pilots while their own forces became increasingly depleted. Major Georg Peter Ader, commanding a Jagdgeschwader 26 Gruppe, later described his amazement at American operational tempo during Big Week. His unit had inflicted what he considered significant damage on American formations during the first day's operations. Intelligence reports suggested that American losses would reduce their effectiveness for subsequent missions. Instead, American formations appeared stronger and more aggressive with each passing day. The mathematics of attrition warfare had been fundamentally altered by American maintenance capabilities. Traditional military planning assumed that aircraft sustaining battle damage would be unavailable for follow-up operations. German tactical doctrine relied on this assumption, with P-51s designed to achieve cumulative degradation of enemy capabilities through sustained combat. When American aircraft proved immune to this kind of attrition, German tactical planning collapsed. Intelligence reports from German reconnaissance flights confirmed what German pilots were experiencing in combat. American air bases showed no signs of the aircraft graveyards that should have accumulated from days of intensive combat operations. Instead, flight lines remained full of operational aircraft. German planners struggled to reconcile these observations with their understanding of combat attrition rates. The psychological pressure on German pilots became overwhelming. Many experienced aviators reported feeling that they were fighting an enemy with unlimited resources and supernatural repair capabilities. Pilot morale, already strained by material shortages and training deficiencies, began to crack under the pressure of facing opponents who seemed immune to normal combat damage. By the end of Big Week, American fighter groups were launching missions with aircraft availability rates exceeding 90%. German fighter units were struggling to maintain 40% availability. The contrast was so stark that German high command initially refused to believe field reports, suspecting exaggeration or incompetence on the part of local commanders. The operational impact extended beyond simple aircraft numbers. American pilots flew with confidence, knowing that minor mechanical problems or battle damage wouldn't ground their aircraft for extended periods. This confidence translated into more aggressive tactics and willingness to engage in prolonged combat. German pilots, aware that any significant damage meant lengthy repair delays, became increasingly conservative in their engagement decisions. Technical intelligence gathered from captured German aircraft revealed the extent of German maintenance problems. German fighters showed signs of deferred maintenance, improvised repairs, and component substitutions that would have been unacceptable in American units. Nowhere patterns indicated operation well beyond recommended limits. Control surfaces showed repair patches that reduced aerodynamic efficiency. Even successful German aircraft were operating at reduced capability due to maintenance constraints. The decisive moment came during the massive air battle over Berlin on March 6, 1944. Over 700 American heavy bombers, escorted by nearly 800 fighters, penetrated to the heart of the German capital in broad daylight. This mission represented the culmination of American strategic air power, made possible by maintenance systems that could sustain such enormous operations. Hauptmann Klaus Mitusch, leading Jagdgeschwader 26 into combat that day, encountered what seemed like an impossible situation. His intelligence briefings had indicated that American fighter strength should have been significantly reduced by previous combat operations. Instead, he found himself facing the largest formation of P-51 Mustangs he had ever seen. The aircraft appeared to be in perfect mechanical condition, showing no signs of the cumulative wear that should have resulted from weeks of intensive operations. The air battle that followed lasted over 2 hours, with combat spread across hundreds of miles of German airspace. American P-51s engaged German interceptors from the Dutch border to the outskirts of Berlin, fighting running battles that tested both aircraft and pilots to their limits. When the smoke cleared, American bombers had successfully attacked their targets, but many fighters on both sides limped home with significant battle damage. At RAF Debden, the 4th Fighter Group's aircraft began landing with extensive damage. Lieutenant James Goodson's P-51 had taken cannon strikes that destroyed his right aileron and damaged his hydraulic system. Captain Don Gentile's aircraft showed over 30 bullet holes and a damaged engine cowling. After aircraft touched down with the kind of damage that should have meant weeks in maintenance hangars. Ground Chief Master Sergeant Joe Hurst surveyed the damage and made rapid decisions that would have seemed reckless to German observers. Instead of conducting thorough inspections and time-consuming repairs, his crews immediately began emergency patches designed to restore flight capability within hours. Aluminum sheets covered bullet holes. Hydraulic lines were rerouted around damaged sections. Engine components were swapped from spare aircraft in the unit's maintenance pool. Within 6 hours, 18 of the 21 damaged aircraft were declared combat-ready. The remaining 3 required engine changes that would be completed overnight. By dawn on March 7th, the entire group was available for operations, despite having sustained what should have been crippling battle damage less than 24 hours earlier. German reconnaissance flights over American air bases reported results that seemed impossible. Instead of the expected aircraft graveyards filled with battle-damaged fighters, German observers saw full flight lines with aircraft being prepared for the next day's missions. Intelligence analysts struggled to explain how American units could maintain such high operational readiness rates despite intensive combat operations. The psychological impact on German pilots was devastating. Oberst Johannes Steinhoff, one of Germany's most experienced fighter leaders, later wrote about the demoralization that spread through German fighter units during this period. Pilots who had successfully engaged American formations and inflicted significant damage found themselves facing identical aircraft within days or hours. The natural assumption was that American industrial capacity was far greater than anyone had imagined. German maintenance personnel, working under increasingly difficult conditions, couldn't understand how their American counterparts achieved such rapid turnaround times. Captured American maintenance manuals revealed standardized procedures that emphasized speed over traditional craftsmanship. German mechanics, trained in methods that had remained unchanged for decades, found these techniques incomprehensible. The strategic implications became clear in the weeks following the Berlin raid. American bomber formations, protected by fighters that seemed immune to normal attrition, began attacking targets throughout Germany with impunity. German air defenses, already strained by material shortages and training deficiencies, couldn't sustain the losses necessary to inflict meaningful damage on American formations. German fighter production, despite heroic efforts by aircraft manufacturers, couldn't compensate for the maintenance disadvantage. New aircraft entering service were often grounded within days due to part shortages or mechanical problems. Meanwhile, American P-51s that had been in combat for months continued flying daily missions with remarkable reliability. The mathematics of aerial warfare had been permanently altered. German planners had based their defensive strategies on assumptions about American aircraft availability that proved completely inaccurate. Plans designed to achieve victory through attrition became impossible when the enemy proved immune to normal attrition rates. By summer 1944, the contrast had become so stark that some German pilots refused to believe intelligence reports about American maintenance capabilities. The idea that aircraft could be repaired so quickly seemed to violate everything they understood about aviation maintenance. Some attributed American success to secret technologies or manufacturing techniques that Germany couldn't match. The statistical evidence of American maintenance superiority became overwhelming by mid-1944. 8th Air Force records showed average aircraft availability rates of 85% across all fighter groups, with some units maintaining over 90% readiness. These figures represented capabilities that no Air Force in history had ever achieved during sustained combat operations. German fighter units, by contrast, struggled to maintain 50% availability rates. Jagdgeschwader 26, one of Germany's most experienced fighter wings, reported only 38 operational aircraft out of an authorized strength of 124 by July 1944. Similar shortfalls affected every German fighter unit, creating a death spiral of declining capability that proved impossible to reverse. Mission success rates reflected these availability differences. American fighter groups flew an average of 1.3 sorties per aircraft per day during intensive operations, compared to 0.4 sorties for German units. This 3-to-1 advantage in operational tempo meant that American pilots accumulated combat experience faster, while German pilots flew less frequently. The experience gap, already significant due to training differences, widened continuously throughout 1944. Combat loss rates showed the impact of maintenance capabilities on tactical effectiveness. Well-maintained American aircraft suffered mechanical failures at rates below 1% per mission, while German fighters experienced mechanical problems in nearly 10% of combat sorties. These failures often occurred at critical moments, leaving German pilots vulnerable when they most needed reliable aircraft performance. Pilot confidence levels, measured through psychological assessments and combat reports, showed dramatic differences between American and German aircrews. American pilots expressed high confidence in their aircraft and maintenance support, leading to aggressive tactics and willingness to engage in extended combat. German pilots increasingly reported concerns about aircraft reliability, contributing to defensive tactics that reduced combat effectiveness. The economic implications were staggering. American maintenance doctrine required higher initial investments in ground personnel, tools, and spare parts, but generated enormous returns through increased aircraft utilization rates. German penny-wise economies in maintenance support resulted in pound-foolish reductions in operational capability that ultimately proved far more expensive than American approaches. Industrial production figures revealed the hidden costs of inadequate maintenance support. German aircraft factories produced over 40,000 fighters in 1944, but poor maintenance meant that only a fraction remained operational at any given time. American factories produced fewer fighters, but maintained much higher percentages in combat-ready condition. Training pipeline analysis showed how maintenance capabilities affected pilot development. American pilots flew their assigned aircraft repeatedly, developing intimate familiarity with individual aircraft characteristics. German pilots flew whatever aircraft happened to be available, never developing the deep knowledge that comes from consistent aircraft assignment. This difference affected combat performance in subtle but important ways. Supply chain vulnerabilities became apparent as the war progressed. German maintenance operations depended on increasingly fragile transportation networks that Allied bombing campaigns systematically disrupted. American supply lines, protected by Allied air superiority and supported by massive merchant marine capacity, proved remarkably resilient to German interference. Quality control data demonstrated how rapid American repairs maintained safety standards despite compressed timelines. Accident rates for American fighters remained stable throughout 1944, despite intensive operations and quick turnaround maintenance. German accident rates increased as maintenance personnel struggled with parts shortages and extended operating schedules. The psychological warfare dimension of maintenance superiority proved as important as its tactical implications. German pilots and ground crews became demoralized by their inability to match American operational tempos. This demoralization affected performance across all aspects of German air operations, creating a downward spiral that accelerated man decline. The long-term strategic consequences of American maintenance superiority extended far beyond the immediate tactical advantages it provided. German Air Force leadership gradually realized that they were fighting an enemy whose operational capabilities exceeded their own by margins they had never anticipated. This recognition fundamentally altered German strategic planning and contributed to the psychological collapse of German resistance. Reichsmarshal Hermann Göring, head of the German Luftwaffe, struggled to understand reports from field commanders about American aircraft availability. His technical advisors assured him that aircraft sustaining combat damage required extensive repair periods. When field reports contradicted these assumptions, Göring initially blamed local commanders for incompetence or cowardice. Only gradually did German high command accept that American military engineering had achieved capabilities that German doctrine considered impossible. The ripple effects spread throughout German military planning. Air defense strategies that had been based on assumptions about American attrition rates required complete revision. Ground commanders who had counted on air support found their requests increasingly denied due to aircraft unavailability. Naval operations that depended on air cover became impossible to sustain as German fighter strength evaporated. German civilian morale suffered as the contrast between German and American capabilities became apparent. Propaganda that had promised German technological superiority seemed increasingly hollow when American bombers appeared over German cities with apparent impunity. The visible failure of German air defenses undermined confidence in German military leadership and contributed to the war weariness that characterized German public opinion in 1944. Industrial planning had to be completely reconsidered in light of maintenance realities. German factories had focused on producing new aircraft rather than supporting existing ones. This emphasis on quantity over sustainability proved to be a strategic error that became increasingly costly as the war progressed. Resources that should have been devoted to maintenance infrastructure were wasted on aircraft that couldn't be kept operational. The technological implications extended beyond aviation to influence German thinking about military engineering in general. German engineers began to realize that their emphasis on precision and perfection, while admirable in peacetime, was counterproductive in wartime conditions. American approaches that emphasize speed and adaptability proved superior under combat conditions, forcing fundamental reconsiderations of German engineering philosophy. Personnel policies throughout the German military reflected the lessons learned from aviation maintenance experiences. The rigid hierarchies and narrow specializations that had characterized German military organization proved inadequate for rapid adaptation to changing conditions. American flexibility and cross-training approaches became models that German reformers attempted to emulate, though cultural resistance limited their success. International perceptions of German military capability were permanently altered by the air war experiences of 1944. Neutral observers who had respected German technical expertise began to question whether German engineering approaches were suitable for modern warfare. This shift in perception affected diplomatic relationships and contributed to Germany's increasing international isolation. Post-war analysis revealed the full extent to which maintenance capabilities had influenced the outcome of the air war. American success stemmed not from superior aircraft performance, but from superior support systems that maximized the potential of available equipment. This lesson influenced military planning throughout the Cold War period and continues to shape modern military doctrine. The psychological trauma experienced by German pilots during this period had lasting effects on survivors. Many German veterans reported that their most vivid memories of the air war involved encounters with American aircraft that seemed to return from the dead. The impossibility of achieving cumulative damage against American formations created a sense of futility that persisted long after the war ended. German technical intelligence efforts focused increasingly on understanding American maintenance methods rather than aircraft design. Captured American maintenance manuals became more valuable than aircraft specifications. German engineers studied American tools and procedures with the same intensity they had once devoted to weapons development, recognizing that operational sustainability was more important than individual system performance. The economic lessons learned from this experience influenced post-war German industrial development. German companies that survived the war adopted American-style approaches to maintenance and logistics, abandoning traditional craftsmanship models in favor of systematic methods that emphasized efficiency and reliability over individual excellence. The story of American maintenance superiority during World War II reveals fundamental truths about modern warfare that extend far beyond the specific technologies and tactics of that era. The German pilots who never imagined that American mechanics could repair P-51s faster than they could shoot them down were witnessing a revolution in military thinking that would reshape warfare for generations to come. Traditional military doctrine had always emphasized the importance of weapons and fighting units while treating logistics and maintenance as secondary concerns. The American experience in World War II demonstrated that this hierarchy was backwards. Superior support systems could overcome significant disadvantages in individual weapon performance. Well-maintained average equipment proved superior to poorly maintained excellent equipment. The unglamorous work of mechanics and supply personnel became as decisive as the heroic efforts of combat pilots. This lesson resonates throughout modern military history. The American success in maintaining high operational tempos during the Gulf War, Iraq conflict, and Afghanistan operations reflected the same systematic approaches to logistics and maintenance that had proven decisive in World War II. The emphasis on standardization, cross-training, and rapid field repairs became hallmarks of American military doctrine that influenced NATO allies and shaped international military thinking. The psychological dimension of maintenance superiority proved as important as its tactical implications. Military effectiveness depends not only on physical capabilities but on the confidence and morale of personnel at all levels. When soldiers know that their equipment will be properly maintained and rapidly repaired, they fight with greater aggression and determination. When they doubt their logistical support, even the bravest warriors become cautious and defensive. The German experience offers sobering lessons about the dangers of neglecting unglamorous but essential military functions. German engineers and military planners had focused on creating superior individual weapons while ignoring the systems necessary to sustain those weapons in combat. This emphasis on perfection over practicality proved to be a fatal flaw that contributed significantly to German defeat. Modern military forces continue to grapple with the balance between technological sophistication and operational sustainability. The temptation to pursue cutting-edge capabilities at the expense of maintenance and logistics support remains strong. The World War II experience suggests that this temptation must be resisted, that victory belongs to forces that can sustain operations rather than those that achieve temporary technological advantages. The mechanics who worked 18-hour shifts to keep P-51 Mustangs flying over Europe deserve recognition as combat heroes whose contributions were as vital as those of the pilots they supported. Their story reminds us that warfare is ultimately a contest of systems rather than individuals, of sustainability rather than momentary brilliance. In the unglamorous work of turning wrenches and patching bullet holes, they forged the tools of victory that made Allied triumph possible.